Good morning, my dear students. I'm happy to meet you all once for a video presentation like this. My friends are asking me whether there are videos for class 9 also. I've uploaded various videos for class 10, 11, 12 of CBSE. In this particular video presentation, we'll think about some introduction about rational numbers, okay, which is meant for class 9 of CBSE. Those who want to have automatic notification about the new videos, please subscribe by clicking the subscribe button as well as the bell icon. This particular concept is dealt with in class 9 of CBSE under number systems. Okay, number system. Okay, just listen carefully. In just first standard or even KG, the teacher would have taught you how to count numbers, etc. 1, 2, 3, 4, etc. Therefore, such a set is known as set of natural numbers. Set of natural numbers. Set of natural numbers. It goes like this: 1, 2, 3, etc. It goes up to infinity. Just imagine that you are giving 3 chocolates to a child. And if you tell the child, if you ask the child how many chocolates are there with you, after counting, the child would answer, I have 3 chocolates. Take one from the child. The answer from the child now would be, I have 2 chocolates. Take one from the child now. The answer would be, I have 1 chocolate left with me. Take the remaining also, last one also. In some cases, the child will cry, or in some cases, the answer will be, I have nothing with me. You have collected everything from me back. Okay, therefore, just to represent absence of things, we Indians introduce a number called 0. Absence of things is denoted by, okay, the number 0. Number 0. Okay, notation for that is something like O symbol. Okay, in English you know O, but it's not exactly O. Okay, now for including 0 along with the set of natural numbers, we have set of whole numbers. We have set of whole numbers. It is denoted as 0, 1, 2, 3, etc. to infinity. Okay, just listen. If we add 2 natural numbers or add 2 whole numbers, the resultant will be definitely a natural number or definitely a whole number. But it is not so in the case of subtraction. If we subtract a bigger number from a smaller number, for example, if I do 4 minus 6, if you know the answer, you will immediately reply, answer is minus 2. But there is no provision to represent such numbers here. Okay, therefore, there is a necessity to introduce another set. Okay, you can call it as I or Z, set of integers. We call it as set of integers. I have starting from minus infinity, minus 2, minus 1, 0, 1, 2, etc. up to infinity. Such a set is called set of integers. Let me just repeat. The teacher would have taught you in lower classes counting of numbers 1, 2, 3, 4, etc. Such a set is called set of natural numbers. After introducing a number called 0, which represents absence of things, along with 1, 2, 3, 4, etc., if I add 0, such a set is called set of whole numbers. There is no provision to represent negative numbers over here. Therefore, adding all negative numbers along with this, I call it as set of integers starting from minus infinity, etc., etc., minus 2, minus 1, 0, 1, 2 up to infinity. Okay, now imagine that I am given a sheet of paper, okay, to represent number 1. Just imagine yourself, okay. If I am going to fold the paper, okay, and once and unfold, I'll get 2 equal halves. I'll get it to be 1 by 2. I'll again fold them twice. Okay, I'll get 4 equal parts like this. Each represents 1 by 4. 1/4 of the whole paper, you know very well. There is no provision to represent such elements in the set of integers. Therefore, there was a necessity to introduce another set. There was a necessity to introduce another set called Q. We call quotient. Maybe because of that we name it as Q. Set of rational numbers. Set of rational numbers. Okay, which is of the form P by Q, where PQ, this symbol is called, is an element of, in set theory you have, is an element of Z, and denominator should be 0. One integer by another integer where denominator not equal to 0 is known as a rational number. Okay. Now, rational number can also be defined in a different way. Okay, any number having a finite decimal or an infinite recurring decimal is called a rational number. That is, whenever I am having a number of the form P by Q, after dividing I will have it in the decimal form. The decimal form, if it ends up at some stage or some number gets repeated up to infinity, that is called recurring. Okay, infinite repeating. Okay, it's called, such a number is called a rational number. Example, think about half, it is 0.5. Example of finite decimal. Okay, think about 1 by 3. 0.33, 3 3s are 9, again 3 3s are 9, etc. Therefore, I will put it like this: 0.3 some bar or 0.3 some dot. 3 gets repeated infinity. Okay, this is example of infinite recurring or repeating. The same number gets repeated. Okay, whenever I am going to bring the decimal form of any rational number of the form P by Q, either it will come under the finite form or infinite recurring form. Okay, there is one more decimal representation which comes under infinite non-recurring. Okay, any number having infinite non-recurring decimal, it doesn't recur at all, non-recurring decimal is called an irrational number. Such a number is called irrational number. Okay, example here will be, are we trying to find root 2, root 3, root 4 is of course 2, you know very well, root 5, cube root of 2, cube root of 7, etc. or examples of irrational numbers. If you know how to think about root of a number, it goes on and on and on, you can't complete. Okay, you can do it throughout your lifetime. Okay, root 2, root 3, or you can even say square root of an imperfect square. 1, 4, 9, 16, such numbers are called perfect square. If the square root of a number is a whole number, such a number is called a perfect square. Square root of any imperfect square, square root of any imperfect cube, okay, are called or examples of irrational numbers. Okay, the set containing both rational and irrational is called set of real numbers. Okay, this is called set of real numbers. Okay, let me write set of real numbers, set of real numbers, set of real numbers, which is equal to union of set of rationals and irrationals. This is the biggest set, or this is a set containing every other set. Okay, it's better not to say biggest. This is the set which contains all the other sets so far, you know, in your number theory. Okay, for the set containing union of rationals, irrationals is called set of real numbers. Therefore, you can just represent as in the circular format. Okay, this is my set of natural numbers. It has 1, 2, 3, 4, etc. Then it is contained in W. Okay, it has one more element 0, 1, 2, 3, etc. Okay, here of course here I have -1, -2, etc. Other than this, okay, this is set of integers, and of course this is contained in again q. Here this is of the form p by q, q not equal to 0 and q not equal to 1 also. When q is equal to 1, it will be in z. Okay, then this is again contained in another set. Okay, this is my set of real numbers. I have, other than rationals, I have irrational numbers also, plus rationals. Okay, rational plus irrational, both will be there, rational as well as irrational. So this is the greatest set which contains the remaining every other set. N is the smallest set we have in mind. Okay, it has elements 1, 2, 3, 4, etc. I have one more element 0 which is not here, which is called W. I have all negative numbers -1, -2, -3, etc. 0, 1, 2, etc. They are called Z. Any number of the form P by Q, Q not equal to 0 is anyway understood, Q not equal to 1, Q is equal to 1, it will be in Z. Those are there in Q. And here I have irrationals as well as rationals, set of real numbers. Therefore, this is how the chain goes. This is how the chain goes. Okay, anyway, remember this base. We will discuss the rest in the next video. Thank you, students, for patient watching.